Southern Europe is expecting an intense heat wave this weekend, with temperatures likely to exceed 40 degrees Celsius in some areas. Spain, Italy, France and Greece have warned about wildfires and the impact of the heat on health.
A sudden and drastic shift in the flow and condition of the Colorado River has triggered urgent concern among scientists, prompting what some have called a red alert in the hydrological community. This abrupt change, which manifested over the course of just a few days, has sent ripples of alarm throughout the southwestern United States and parts of northern Mexico, where the river's lifeblood supports tens of millions of people, vast agricultural lands, and fragile ecosystems. For decades, scientists have monitored the Colorado River closely due to its sensitivity to climate change and increasing demands from human development. But nothing in recent memory compares to the gravity of this sudden transformation. Before we start, hit the like and subscribe buttons for more exclusive news. At the heart of this shift lies a sharp drop in water levels combined with an unseasonable warming event that accelerated snowmelt and evaporation at unprecedented rates. Within the span of a week, sensors placed throughout the river basin recorded both erratic surges and rapid depletions in water volume, a contradiction that left many experts stunned. These patterns defied seasonal expectations. June is typically a period of steady, if not predictable, runoff from the Rocky Mountain snowpack, but instead, a powerful atmospheric anomaly led to a temperature spike across high-altitude zones, triggering a massive compressed melt-off. The sudden influx of meltwater surged downstream faster than usual, flooding certain lower basin areas briefly before being absorbed or evaporated. Simultaneously, high winds and extreme heat intensified evaporation rates in major reservoirs like Lake Powell and Lake Mead. Within days, water levels plummeted, not gradually but precipitously, revealing dry banks and dislodging aquatic life. Such a rapid and intense fluctuation disrupted aquatic ecosystems, upset dam operations, and confounded water managers from Utah to California. One particularly jarring result of this event is the appearance of deep fissures and sinkholes near parts of the riverbanks, where rapid water withdrawals destabilize sedimentary structures. In agricultural regions that depend heavily on irrigation sourced from the Colorado River, farmers reported unusual soil cracking and dust storms forming over what had just weeks before been green, fertile fields. The accelerated drawdown of moisture from both the soil and the river left farmlands parched and vulnerable to erosion, a stark foreshadowing of longer-term degradation if this new pattern continues. The Colorado River has long been over-allocated, with more water promised to users than what the river naturally produces in a year. This latest event starkly underscores how close to the edge the entire river system has come. With the sudden shift, not only were previous calculations rendered obsolete, but entire frameworks for managing interstate water sharing were thrown into disarray. Water authorities scrambled to assess the real-time data, but what they found pointed to an unsettling conclusion. The river's behavior has entered a new, volatile phase. Adding to the complexity is the role of glacial remnants and high-altitude ice fields that feed the Colorado River. Satellite imagery showed rapid degradation of these sources following the heat surge, suggesting a possible permanent loss of some critical snow and ice storage zones. These sources historically acted as natural regulators of river flow, releasing meltwater slowly over time. Their potential disappearance would mean a future where the Colorado River is subject to even more extreme swings between drought and flood, leaving communities with little ability to prepare or adapt. Urban centers like Las Vegas, Phoenix, and Los Angeles, which depend heavily on water diverted from the river, are beginning to feel the psychological weight of this new instability. Though water does not immediately stop flowing from household taps, the specter of rationing, restrictions, and infrastructure strain has become more tangible. In some regions, municipal water managers have begun issuing advisories, not just about usage, but about preparing for more severe disruptions down the line. Industrial sectors, especially those requiring water for cooling and processing, are already assessing potential impacts on production timelines and output. Ecologically, the consequences are unfolding in real time. In the Grand Canyon region, which relies on a consistent flow of water to sustain endemic plant and animal species, the sudden fluctuation in flow rates has triggered localized ecological collapses. Sensitive fish populations like the humpback chub experienced high mortality due to shock changes in water temperature and chemistry. Riverbanks, once lush with riparian growth, have turned brittle in places, with birds and mammals seen abandoning usual nesting sites in search of more stable habitats. The speed of change has left little time for adaptation, emphasizing the vulnerability of biological systems already living on the edge. Dam operators at Hoover and Glen Canyon were forced into emergency mode during the event, adjusting outflows and power generation schedules with only hours' notice. The hydropower infrastructure along the Colorado River depends heavily on consistent water levels to function efficiently. The sudden decrease in reservoir height threatened to dip turbines below their operational thresholds. Although blackouts were narrowly avoided, the event revealed just how fragile the energy network tied to the river really is. For millions, this raises the specter of a cascading crisis, where water instability leads directly to energy shortfalls. Further downstream, the Salton Sea and other terminal basins that receive overflow from agricultural drainage saw sudden chemical shifts. The unexpected drop in freshwater input concentrated salinity and pollutants, increasing toxicity for both aquatic life and surrounding communities. Several fish kills were reported within days, and local residents began reporting respiratory issues as particulate matter from the drying lake beds was carried on the wind. These secondary effects of the river's transformation point to a web of interconnected crises, each feeding into the next. What makes this event particularly alarming to scientists is not merely the intensity of the change, but the lack of precedent. Past years have brought drought, flood, and warming trends, but this event combined all three phenomena in a compressed timeline, with little to no warning. It suggests that the Colorado River is now operating under a new set of environmental rules, ones shaped more by volatility than predictability. This has enormous implications for every legal, logistical, and ecological system tied to the river. The science community, long sounding alarms about the unsustainable use and changing climate of the Colorado Basin, is now faced with the reality that theoretical worst-case scenarios are manifesting more quickly than anticipated. Data modeling that once projected certain thresholds being crossed in the next 20 to 30 years must now be revised to reflect the immediate present. This recalibration includes estimates of water availability, reservoir life expectancy, and the resilience of dependent communities. From an atmospheric perspective, the convergence of jet stream anomalies, high-pressure heat domes, and land-atmosphere feedback loops created a kind of perfect storm over the basin. The warming of high-altitude snowpack, when combined with prolonged dryness in lower altitudes, generated a situation in which the entire watershed system became hyper-responsive. The Colorado River, no longer buffered by a consistent hydrological rhythm, has effectively become a system where extremes rather than averages define its behavior. Infrastructure built to control the river, such as aqueducts, canals, and diversion tunnels, now appears ill-suited for such rapid transitions. These systems were designed with 20th century climate patterns in mind, calibrated to a river that, while variable, rarely shifted so violently and quickly. Now these same infrastructures may become liabilities, rigid pathways in a fluid world. Emergency releases and ad hoc water storage maneuvers may become more frequent, leading to increased maintenance costs and a higher likelihood of structural stress or failure. Legal frameworks built around the Colorado River, particularly the 1922 Colorado River Compact and its subsequent amendments, now face an existential challenge. These agreements were based on a false premise that the river would remain relatively stable and generous. The new data suggests otherwise. States that were already in conflict over water rights now face an even more contentious environment where not only is there less water to divide, but the timing and location of that water may change unpredictably from year to year or even week to week. Public reaction in many communities ranged from confusion to panic. Rumors of water shutoffs, although unfounded in the short term, circulated rapidly across social media. Local governments were forced to respond with both reassurance and realism, acknowledging the seriousness of the situation while avoiding mass alarm. Water hoarding began in some areas, and garden stores saw a rush on drought-resistant plant species. There's a growing sense among the public that something foundational has shifted, not just about the river, but about the future of life in the American Southwest. Tribal communities, many of which have historical and legal claims to Colorado River water, were among the first to raise concerns about how this sudden event would affect their sovereignty and resource security. Already underserved and often excluded from major water planning initiatives, these communities now face additional threats to their agricultural traditions, ceremonial practices, and economic stability. For them, the river is not just a utility but a living entity, and its sudden transformation carries both spiritual and practical consequences. In scientific circles, there is growing acknowledgement that this may be a tipping point, not only for the Colorado River, but for how humanity approaches river systems in the age of climate disruption. For years, the idea of stationarity, the notion that natural systems fluctuate within a fixed range, has been eroding. Now, the Colorado River demonstrates that even the concept of gradual change may be outdated. What we are witnessing may be better described as hydrological upheaval, an unraveling of old patterns in favor of something less stable, less forgiving. Efforts to model the river's behavior going forward are underway, but confidence is low. The inputs that drive these models, historical flow data, snowpack conditions, temperature projections, no longer correlate in predictable ways. Scientists are now tasked with creating adaptive models that can respond to rapid change in near real time. This represents a major shift in the field of hydrology, from predictive science to something more akin to responsive navigation. The river is no longer a slowly shifting puzzle to solve, but a dynamic force to react to moment by moment. As this red alert reverberates through policy circles, it's clear that the path forward will require unprecedented cooperation, innovation, and perhaps sacrifice. Urban centers may need to reimagine their growth models. Agricultural regions may have to pivot away from water-intensive crops. Lawmakers may be forced to reconsider long-held entitlements. And communities up and down the river may have to face the stark truth that a reliable Colorado River can no longer be taken for granted. All of this, triggered by a single sudden shift, an unexpected and jarring reminder of how vulnerable even the most engineered systems are in the face of a changing planet. The Colorado River has always been a symbol of both opportunity and constraint, shaping civilizations, economies, and landscapes across the American West. Now it stands as a harbinger of a future defined not by abundance or even scarcity, but by volatility. A river not just drying or flooding, but breaking free from the bounds of human expectation. The urgency behind the red alert triggered by the Colorado River's sudden transformation stems not only from the immediate hydrological consequences, but also from the systemic vulnerabilities it has exposed. In a matter of days, the foundational belief in the reliability of one of the most managed and regulated river systems in the world was fundamentally shaken. This event has unveiled layers of dependency and fragility within infrastructure, governance, and the fabric of communities reliant on this vital waterway. At the forefront of scientific concern is the failure of forecasting tools that had, until recently, been trusted to predict seasonal flows and long-term trends. These models, calibrated with historical data, were caught off guard by the scale and speed of the transformation. The atmospheric patterns and thermal anomalies that catalyzed the sudden shift were not entirely absent from predictive frameworks, but their intensity and timing far exceeded anticipated parameters. This discrepancy has called into question the broader reliability of climate and hydrological models across the western U.S. and other similarly stressed watersheds around the globe. The Colorado River is unique in that it cuts across multiple climate zones, from alpine forests to deserts, which historically allowed it to buffer stress through geographical diversity. This sudden change has indicated that even this buffer is beginning to collapse. The zones once relied upon to stabilize flow, particularly snow-laden upper basin regions, are themselves succumbing to the accelerating pace of climate disruption. What this suggests is a narrowing of natural resilience. The system is no longer able to absorb shocks without immediately manifesting large-scale dysfunction. Power generation from hydroelectric facilities is under renewed scrutiny as a result of the event. Beyond the narrowly avoided operational failures at key dams, the incident revealed how energy networks are tethered to natural systems in ways that are increasingly untenable. Hydropower has often been viewed as a clean and renewable energy source, a linchpin in the green transition for many southwestern states. But this incident has emphasized a stark truth. The greening of energy portfolios cannot proceed blindly, divorced from environmental realities. Planning must now factor in extreme and unpredictable water scarcity as a persistent threat, not an occasional disruption. Moreover, the sudden changes in the river's behavior have sent economic shockwaves through sectors often overlooked in water policy debates. River-based tourism, particularly rafting, fishing, and ecological sightseeing, has seen immediate cancellations and disruptions. Low flows and unpredictable rapids have rendered many stretches of the river unsafe for recreation. Businesses built around the predictability of seasonal flows, from small outfitters to major park concessions, are now grappling with how to survive in an era of chaos. This economic fallout, while less publicized than urban water shortages, is deeply felt in rural communities where tourism often serves as a primary economic engine. The event has also drawn renewed attention to groundwater systems connected to the river. As surface water levels dropped, a sudden and aggressive uptick in groundwater pumping was recorded in agricultural and suburban areas. Aquifers, already depleted from decades of overuse, are now being leaned on even harder as communities attempt to bridge the gap created by the river's instability. But this stopgap measure is inherently unsustainable. Aquifer recharge rates are declining, and in some cases, irreversible land subsidence is being observed. It's a silent collapse beneath the surface, one accelerated by a river system that no longer behaves predictably. In tandem, water quality issues have intensified. With less flow to dilute pollutants, concentrations of nitrates, heavy metals, and agricultural runoff have spiked in several key stretches of the river. In smaller communities that rely on untreated or minimally treated river water for domestic use, this has led to localized health advisories and a scramble for alternative water sources. Water purification systems, already underfunded in many rural areas, are now being pushed beyond their design limits. The public health implications of this event may extend far beyond drought and into chronic exposure to contaminated water. Beyond the physical and economic impacts, there's a cultural and psychological toll emerging from the river's sudden shift. The Colorado River has long stood as a symbol of life and persistence in the arid West, woven into the identity of indigenous nations, farmers, environmentalists, and city dwellers alike. This event has fractured that narrative. The shock has left many feeling untethered, questioning the viability of long-term residence in regions that once boasted limitless promise. This is especially true for younger generations, whose futures are now marked by deep uncertainty regarding water security, climate resilience, and environmental justice. Policy discussions, usually mired in bureaucracy and litigation, have taken on a sharper, more urgent tone in the aftermath. Emergency meetings between state water agencies have begun, with calls for a federal intervention growing louder. Yet even as negotiations proceed, the event has revealed a troubling reality. There is no single fix. The scale and unpredictability of the river's new behavior demand not only reactive measures, but a complete paradigm shift in how water is valued, managed, and distributed across the West. Education and public engagement, often slow to adapt to emerging crises, are being re-examined. Schools in river-dependent regions are introducing climate adaptation into curricula, while local leaders are organizing community forums not just to explain the event, but to brainstorm paths forward. The language of resilience and transformation is replacing that of conservation alone. There is a growing recognition that returning to the previous status quo is not only unlikely, it may be dangerous. The focus must now shift toward flexible, dynamic systems that can withstand not just drought, but disorder. Technology, too, is being called upon to fill new roles. Satellite monitoring systems, real-time water tracking platforms, and advanced AI models are being deployed to observe and predict short-term changes in river conditions. These tools may offer the precision needed to react more effectively in the future. However, the event has demonstrated that technology alone cannot substitute for foundational systemic reform. Without deep changes to policy, behavior, and infrastructure, even the most advanced systems will be overwhelmed by the pace of change. This sudden upheaval of the Colorado River marks more than an environmental crisis. It is a historical moment of reckoning. It has laid bare the limits of human control over nature, the dangers of assuming permanence in an age of disruption, and the urgent need to transition from reactive management to anticipatory governance. As scientists continue to monitor the shifting patterns, and as communities begin to reimagine their relationship with water, one truth is now clear. The age of certainty in the American West is over. What lies ahead is a future defined not by equilibrium, but by the ability to adapt swiftly and wisely to the river's new volatile rhythm. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the sudden Colorado River change? We want to hear from you. Thank you for watching and see you next time.